All right. So, all of you are on page 129 now, and all of you are looking at this. And all of you are looking at this, and you are all recognizing what math is happening right there. That's multiplication. Which means I'm multiplying two things, which means this is a factor, and this is a factor, right? Now, since it's letter, letter, number, number, can I do my shortcut? So, what is the answer? X squared plus, and then I add 4 plus 6 with an X, right? And the last part is 4 times 6, correct? Which takes me to x squared plus 10x plus 24. Is everybody good? Right? Now, what really happened there was I had x plus 4 times x plus 6, and I did distribution twice. And I got x squared plus x times 6, 6x, plus 4x plus 24. And then I added it up to get x squared plus 10x plus 24. But, of course, you know that if you know both factors, 3 and 4, you can multiply them together to get a product of 12, yes? But if you need the factors of 12, you have to divide, right? So going this way was multiplying, expansion. Going the other way is division, factoring. Now, you should all notice that when you have this set up, if you get to this point, which is squared, variable, constant, you should be able to get back to the factors. And the way you do that is by recognizing that the last step is adding and multiplying to get this middle number and to get this, yes? So that must mean that if I know the numbers that multiply to 24 and add to 10, I know what these numbers are going to be. Now, all of you who are in grade 10 already know how to do this. All of you that are in grade 9 maybe have never seen it before. Depends on your teacher. If your teacher had a little bit of extra time and knows where you're going in grade 10, your teacher probably showed you this. If he or she didn't, that's okay, because you're going to learn it right now. So, the only thing you have to worry about are these signs. That's what causes the problem. So, x plus a, x plus b. When I multiply all that out, I'm going to end up with plus and plus, right? That was plus, and my answer was plus and plus. Yeah? All right. If it's minus a plus b, then I'm going to end up with what? What's going to be the second one? If that's negative and that's positive, this will have to be negative, right? This one could be either, right? And if it was negative and negative, this one will be plus or minus. And in this one, if it's negative and negative, then what's it going to be? It's going to be a positive at the end. And this one would be what? Have to be negative. Everybody okay? Let's practice it a little, because really that's how easy it is. So I look at this and I say to myself, all right, I know that this is going to end up looking possibly like this. Plus or minus a number and x plus or minus another number. So let's check it out. I have to multiply to that number, which is negative 18. And I have to add to that number, which is 7. So now what I got to do is I have to list numbers that will multiply to 18. Now, I only can use pairs, right? Because there's only a spot for 2 here. So is it 1 and 18? 1 and 18. Will they make 7 in any way? No. What about 2 and 9? 2 and 9 will not make 7 in any way. 9 minus 2 will not be 7. It will be 7, won't it? So I know that it's that pair. Now I have to look up here. How do I make 9 and 2 make 7? Positive 7? Is it 2 minus 9? Or is it 9 minus 2? It's 9 minus 2. So now I go back over to here, and I know that my answer has to be x plus 9 and x minus 2. And then I can check it really easily, can't I? Because that's letter, I can just do the shortcut. Is 9 minus 2 7? Yes. Is 9 times negative 2 negative 18? So I did it right. Can everybody factor? The hardest thing is deciding the factors here. So let's look at this one. It's minus and minus. So if it's minus and minus, what does that mean the answer is going to be? We know it's going to be x squared, and then what? It's got to be a minus, and it's got to be a what? Positive, right? Because I need a negative number to multiply a positive number to get a negative number. And I need to multiply to what? Negative 8, and I need to add to what? Negative 2. So let's do our factors first. Is it 1 and 8? That will not get me to 2 in any way. Is it 2 and 4? Yes. How will 2 and 4 get me to negative 2? Negative 4 plus 2, right? So I know it's negative 4 and positive 2. Now I simply go to here. Shouldn't have been x squared. Minus 4 plus 2. And then I check. Negative 4 plus 2, negative 2. Negative 4 times 2, negative 8. Gotcha. That's how easy it is. And it will follow this pattern forever. Except when it doesn't. And we'll talk about that in a minute. So you guys do C. What do I got to multiply to? What do I got to add to? Multiply to 35. Add to negative 12. Is it 1 and 35? Nope. Is it 5 and 7? Okay, how will 5 and 7 get me to negative 12? They both have to be negative. Negative 5 and negative 7 is negative 12. So this is x minus 5, x minus 7. Can everybody factor? Great. What's D? Multiply to what? Add to what? Multiply to negative 20 and add to 12. What is it? Okay, so the guess is 10 and 2. How will 10 and 2 get me to 12? You're going to add them, make them both positive. Positive 10, positive 2. Okay, that means it's a plus 10, a plus 2, correct? Right? 10 plus 2 is what? Excellent. What's 10 times 2? What kind of 20? Positive 20. What kind of 20 did I need? We'll come back to that when you're back. All right. So, this one's troublesome, right? Because you're like, oh, it's 10 and 2. 10 and 2 makes 12. Except 10 and 2, when they multiply together, doesn't make negative 20, does it? Okay, Mr. Meyer, so it's negative 10 and 2. No, because negative 10 and 2 won't make 12. Okay, so it's negative 2 and 10. No, because negative 2 and 10 won't make 12. So what do you do when this happens? It's very simple. This does not factor. There is no way to factor it. Now, you will notice that we did 4 examples on this page, yes? 3 of them factored, 1 didn't. Here is what is going to happen. I need to show you what it looks like when it's tricky, right? And it doesn't factor, because this really looked like it was going to factor. But the problem I've found with this unit when I teach it is once you people see that it's possible that it might not factor, if you can't figure it out in about 2 seconds, you write, does not factor, and move on to the next question, even if it will factor. Does everybody understand what I'm saying? Try them first. Actually try them. If you have to, list the factors like I am doing to make sure that it does not factor, okay? Before you use that cop-out. So, there's going to be a few on this page, page 130, that are going to cause you're going to want to say DNF, but they factor, okay? So, let's look at page 130 and let's go through it. E looks pretty normal. What should I multiply to? Look again. Negative 14. And what should I add to? Negative 5. So, is it 1 and 14? No. Is it 2 and 7? How? 2 minus 7 will get me negative 5, right? So I know it's x plus 2, x minus 7. Yeah? Easy peasy lemon squeezy. Tell me why you cannot do F yet. Even though all of you know how to do F, except for maybe the grade 9, looking at F, what about that makes you uncomfortable? Pardon me? The 4 at the front, for sure, right? Because in every other example, there's been no 4 at the front, right? But we know from this page what we're supposed to do, yes? Right? So we go back to where we were, and we see, I don't like that 4 there. I want to get rid of it. The only way to get rid of something times 4 is divide by 4, right? And then we check, does that work all the way across? Does 20 divide by 4? Yup. Does 56 divide by 4? Yup. So we can get a 4 out of there. So this is really 4x squared minus 5x minus 14. Now, look at that. Look at that. Aren't they the same thing? Right? This is the first kind of factoring that is going to mess you people up, because you're going to see the greatest common factor, 4, 4, 4, and a bunch of you are going to stop there. Because you're going to say, I factored it, I'm done. But you're not done. The reason I wrote this one here is to make you see that it's the same as that. So I have to factor again. Okay? Now, when we're multiplying, does order matter? When we're multiplying, order does not matter, does it? Because negative 2 times 7 is negative 14, and negative 7 times 2 is negative 14, correct? But in factoring, we also care about the adding. So we have to get this order correct, right? I cannot put, this would be wrong, x plus 7 and x minus 2. Even though 7 times 2 will get me the negative 14 I need, 7 minus 2 gets me positive 5, not negative 5. So be mindful of that. Everybody good? All right. What's wrong with G that bothers you? You don't like the 10. Can you get rid of the 10? How? Everything divides by 10. And we should always try and start with GCF. So now I've got x squared plus 8x plus 12. Now, I might be able to factor that. Let's try. If I can factor it, I need to multiply to what? 12 and add to what? 8. Is it 1 and 12? Is it 2 and 6? Yep. So it's 10, x plus 2, x plus 6. Everybody good? All right, now, build on what you already know. What bothers you about h? The 4 and what else? The fact that the 4 is negative. Because we only know how to factor when there's nothing out in front. No negative and no number. So let's see if we can get rid of that number. Negative 4. Negative 4 works with 16. Does negative 4 work with 128? Maybe you know, maybe you don't. Do you have an easy way to check? Get out your calculator. Negative 4. T squared. What's this going to be? No. 4. Positive 4t. And what's this going to be? Negative 32. So now I got to check this. Can I forget about the 4? No. And if this is going to work, I have to multiply to what? Negative 32 and add to what? 4. Is it 1 and 32? Is it 2 and 16? Is it 4 and 8? It is. 4 and 8. How will 4 and 8 get me to 4? 8 minus 4. So it's t plus 8, positive 8, t minus 4, negative 4. Is everybody good? Now, usually this is the unit where people start to get a little off the rails in Math 10. Because all of a sudden, there's no diagrams. You can't do it with a calculator because you can't go square root of 7. And there's all these letters running around. So be careful, go slowly, and make sure you know what you're doing. Look at I and tell me what bothers you about I. What bothers you, Sophia? You don't like... Yeah, you don't like the order, do you? Can we change the order around? So if I were to change this order around to an order that I like, what would it be? We'd put the d first, wouldn't we? So this would become negative d squared minus 5d minus 24, correct? Everyone agree? Do I have all the same stuff? Yep. Now what don't I like? I don't like that negative because we only know what to do if that's got nothing in front of it. So I'm going to divide out a negative 1. So negative 1, and that gives me d squared plus 5d plus 24. Can I factor that? If I can, I need to multiply to 24 and add to 5. Is it 1 and 24? Nope. Is it 2 and 12? Nope. Is it 3 and 8? 3 and 8 is our best choice. How can I make 3 and 8 give me 5? 8 and minus 3. Now go over here and check. They're both positive. Is there any way to make that guy positive if one of these is negative? No. So does it work? No. So this is the only factoring we can do. Even though this looks like it factors, it looks good, but it's not. So the only thing we can do is take out a negative. Is everybody good? All right. Look at J and tell me what bothers you. Different letters. But we've made enough fun of the people that can't do math if we change the letters, right? So that's, we know what to do. What else bothers you? You don't like the second letter, do you? But, again, this is something that makes math teachers go crazy. A bunch of you will say you can't do that. But if I do this, could you all do that now? You would need to multiply to what? 2. What kind of 20? Negative 20. And add to what? 19. Is it 1 and 20? Yep. It's 1 and 20. How do I make 1 and 20 get me to 19? 20 minus 1, correct? So it would be v plus 20 and v minus 1. Agreed? Everyone agree? That's if the b's weren't there. But the b's are there. How do you make a b squared? It's b and b, isn't it? B, B. And I'm done. What you knew how to do with something else you knew how to do, because you know b times b is b squared, and then you're done. Now, the only thing I would change there, what's the one number that we really don't want to write there? We don't want to write that 1. So the best answer is v plus 20b and v minus b. But would I accept this? Of course I would. Everybody good? Great. So now you all know how to do k, right? Because you could all do k in your sleep if it was that. So make it happen. I need to multiply to what and add to what? Is it 1 and 28? No. Is it 2 and 14? Yes. How do 2 and 14 get me to positive 12? 14 minus 2. X plus 14. X plus 14 what? Y. X minus 2. Y. Why do I need that y? Why? Because at the end, I need to have y times y to make y squared. Is everybody good? Now notice, you guys really need to be noticing something. Every time I show you something new, what's the first thing I say? What don't you like about this, right? Because I never give you something you can't do. Correct? So, always go back to your original knowledge and build from there. What don't you like about L? You don't like that B, which means you don't like that B, right? And you don't like that B. You could do that easily, couldn't you? Okay. What else do you notice? What's in all three of them? B, the thing you don't like. How do I get rid of something I don't like? I divide it out. So if I divide a B out of here, I'm GCFing, aren't I? Where does that GCF go? To the front. And what's in here? All the answers, which is a squared minus ab minus 20b squared, correct? Now this looks exactly like these guys with the squared at the end, yes? Does anything change? No. I multiply to what? Negative 20, and I add to what? Negative 1. Is it 1 and 20? 1 and 20 will get me to negative 1. Is it 2 and 10? Is it 4 and 5? Or does it not factor? Because those are your only options. It is 4 and 5. How? 4 minus 5 gets me negative 1, yes? So there's a b on the outside, so we can't forget about him. This is a plus 4 what? Plus 4b. And a minus what? 5b. And we're done there. Is everybody okay? Because that's about the second trickiest thing I can do to you. Is everybody good up to L? Okay. So let's look at M. What is the first question I'm going to ask you? What don't you like about that? What don't you like about M? It's x to the 4th. Now look at what you already know. When I started at a squared, my answer was a and a. When I started at x squared, my answer was x and x. What is the relationship between x squared and x, and a squared and a? A times a is a squared, correct? And x times x is x squared, correct? We know that this first term is going to get squared, don't we? When we do FOIL, it's going to get squared, right? So, are we doing FOIL here, or are we doing the reverse of FOIL? We're doing the reverse, which means that first term is going to get what? In FOIL, we square it. When we're factoring, we're reversing FOIL. So what's the reverse of square? Square root. So that means the first term here must be x squared and x squared, because x squared times x squared is x to the 4th. Now, do you think anything else changes? Let's see. I need to multiply to what? 50, and add to what? Negative 15. Is it 1 and 50? Is it 2 and 25? Is it 5 and 10? How? How do 5 and 10 get me to negative 15? Negative 5 and negative 10. Two negatives will get me to negative 15, and when they multiply, they'll get me positive 50. So this is x squared minus 5, x squared minus 10. Negative 5 and negative 10 is negative 15. 5 times 10 is positive 50. X squared times 10, x squared times 5, negative 15x squared. Is everybody good? Okay. Now, n is written in a stupid way, because the next thing I'm going to teach you, this is very helpful for it. Because what would we really write here instead of this? What's this really? X squared minus 9. 0x is 0, isn't it? Right? So that's what this really is. What I'm about to teach you next will use this. But to get there, I want to do this. Since I've written this out as a trinomial, it must factor as a trinomial, yes? So that means I need to multiply to negative 9 and add to what? 0. Is it 1 and 9? Is it 3 and 3? Yes. How does 3 and 3 get me to 0? 3 minus 3. So it must be x plus 3, x minus 3, correct? What about this one? I need to multiply to negative 625 and add to 0. Now, you guys are smart people. Look what happened. Look at the relationships. Look at the patterns. X, X, X. Y, 3, 3. What's the pattern? And I'd really like to hear this from a grade 9, not a grade 10, because all the grade 10s have already seen this. They're square roots, aren't they? So what do you think might be an answer here when I have squared and 625? X plus the square root of 625. 25. X minus 25. Cool? Okay. Now look at P. What do I got to multiply to? 16. What do I got to add to? 8. Is it 1 and 16? Is it 2 and 8? Is it 4 and 4? Yep. X plus 4. X plus 4. Now I want you to notice something here. I have an x squared, x and x. What is special about 16? It's a square root, or it's a perfect square, yes? There's my 4 and 4, yes? Why is N and O different from P? Because in M and O, this middle term isn't really there, is it? Why is it there here? Because they're both positive. Right? Because they're both positive, there has to be a middle term, so it can't drop out. Because one of these is positive and one is negative, I'm going to end up with plus 25 minus 25, aren't I? Which is 0. Is everybody good? Excellent. Page 131 and 132 up to, but not yet including 8, 9, and 10. Do everything on 131 and 132 except 8, 9, and 10. Okay? Go. Okay. Doop. Be doop. Be doop. Be doop. 10:05. What do we got here? Oh, got lots of time. Okally-dokally. Page 131. What's the first one? Everything's worth 1 mark. What's the first one? What's coming out? A. What's staying in? A squared minus x. Done. What's coming out? 9. What's staying in? D squared plus 3. What's coming out? 5x cubed. What's staying in? 2 minus 5 xy. What's coming out in 4? 3x. What's staying in? 9x squared minus 16. Now, some of you may take that further because you've done grade 10 already. But if you've gotten that far, you get 1 point. The 1 point that's available. This one, multiply to 64, add to 20, and it is, of course, x plus 16 and x plus 4. This one, what's weird about it? Don't like the order, so you change the order. And it is x minus 5. X plus 8. X minus 8. X. Ooh. Tricky. Tricky McTrickleton. X cubed plus 12. X cubed minus 12. X minus 2. X minus 9. 2 x squared plus 14x plus 13. If you got that far, you got a half a mark. But of course, you finished it to x plus 13, x plus 1 to get the whole mark. X squared plus 5, x squared minus 2, and a minus 6b. That looks like bb, but it's 6b. And then you could have written it like this, a minus 6b, or better, a minus 6b squared. I'll accept them both. That page is out of 12. Yeah? That's the assignment. This page, what's it say? Practice. So you should have been practicing. And everybody should have kicked this page's butt until number 8. Z plus 8 and z minus 5. This one, y plus 4, y plus 5. This one, ooh, tricky. What do you see there and there? So it's x squared plus another x squared. No, 2x squareds. What do you see there and there? X's. Negative 3 minus 9 is negative 12x plus 8. Now, you notice you can take a 2 out of there. X squared minus 6x plus 4. And then multiply to 4, add to 6. Do they exist? Is there any numbers that multiply to 4 and add to 6? 1 and 4 or 2 and 2? Do they add to 6 in any way? So am I done? Yes. This one. What do you see there and there? K squareds. So that's 18k squareds minus 18k. What's in both? 18k. Leave me with k minus 1. A lot of you will forget that 1 because you've taken the 18k out. What's common? 6x cubed y. Then I write the answers. 4x minus 3. Done. And this one, x plus 9, x minus 9. This one, what's different? Ooh, tricky. X squared plus 16, x squared minus 16. I bet everybody got to there, but I bet not everybody saw that. And did x squared plus 16, x plus 4, x minus 4. If you got to there right now, you get full marks. Well, if we were marking this. This is practice. Now, we get to the tricky stuff. This should bother you until you stop for a moment and check. What do you notice about that and that? They're the same. What math is happening there? Multiply. What math is happening there? So that makes this x a factor, doesn't it? And what does that make this whole thing? Another factor. What does that make that 3? A third factor. What does that make that x squared? X minus 2, I mean. No, it's not a fourth factor. It's the same as this, isn't it? So, doesn't that mean that those two are common factors? So we're going to get rid of them, right? And we get rid of them by dividing by the common factor. The common factor goes outside, and what stays inside? The answers. x2 and x2 cancel, leaving me with x. x2 and x2 cancel, leaving me with plus 3. That's my answer. Now, I'm going to give you guys an extra thing here that might help some of you out, because a lot of kids have trouble seeing this. Even though we can see right there, factor 2 and factor 2, they're the same thing. Watch. As soon as I see two factors are the same, I make them the letter A. A equals x minus 2. Now, what do I have here? I have x times A, because A is x minus 2, plus 3 times A. Now you can quite plainly see A is in both of them, correct? Divide both by A goes outside, and I get x plus 3, right? But there is no A in the original question, because A is x minus 2. So what do I write here now? X minus 2, x plus 3. And I get the same answer. Do I care what you do? No. But this bit of math trickery is really, really, really a handy piece of math trickery. You can use that a buttload of times between now and the end of grade 12. Will that trick I just showed you work here? Yes, because these are the same, aren't they? So we know this thing is going to end up out front, A minus B, because of what we just did. And what's on the other side? 2A plus B. Right? Now, 10 always causes crap. Why? Those two look very similar, don't they? But are they? No, because it's positive 2x and negative 2x. And negative 3 and positive 3. But what happens if I divide this by negative 1? Then I've got x, 2x minus 3. If I divide this by negative 1, then I got to bring a negative 1 out front, don't I? That negative 1 is now part of this coefficient. What's negative 1 and negative 5 multiply to? Positive 5. Now, what is 3 divided by negative 1? Negative 3. What is negative 2x divided by negative 1? Positive 2x. And oh, look what happened. Why am I allowed to do this? Because 1 is a factor of everything, isn't it? So I can always divide out a 1 if I need to change the looks of something. Now, since they're both the same, son of a 2x minus 3. And what's on the other part? X plus 5. And then the last two you already knew how to do. This one, already on your quiz, this type of one was causing people some trouble. X plus 3, x plus 3, x plus 3. I like to do the second set first. I can do the shortcut, x squared plus 6x plus 9. Then I got to run this. X cubed plus 6x squared plus 9x plus 3x squared plus 18x plus 27. Then I add it. X cubed plus 9x squared plus 27x plus 27. Now I noticed in all the quizzes while I was marking, there are not a lot of people that are stacking this up the way I stack it up. Which is fine, because I never will penalize you for doing your work differently than I will. except when you get the wrong answer. Because a lot of people that didn't stack this up got the wrong final answer. A lot of you are doing this. Okay, you get to this spot, fine. Then you're going, all right, x cubed plus 6x squared plus 9x. And then you're going in a row, and you're going plus 3x squared plus 18x plus 27. Then you're trying to add them up horizontally, and you're making computational errors. You're doing the polynomial part, fine. You're doing the grade 10 stuff, fine. What you're screwing up is adding and subtracting your negative numbers, which you learned in grade 4, 5, 6, whenever it was. So be careful. If you don't want to stack them up like this, I don't know why you wouldn't, because it lines them up perfectly so you get your like terms. But if you don't want to do that, don't. But make sure you have done the correct adding and subtracting. Okay? And the last one is, of course, 10x squared minus 6xy plus 20xy minus 12y squared. 10x squared plus 14xy minus 12y squared. And that's done. The only marks you should have is this page out of 12, page 131. I will get that mark from you when you do your... I'll get it from you soon. I don't know when. What? That's on the next page. Okay, is everybody good with the two kinds of factoring we have done so far? Everybody. All ya all. Which is how you say plural when you're talking to everybody and you're from the South. If I was only talking to one of you, you would be y'all, which I don't really understand. Zach is you all. But Zach and Avian are all ya all. I don't get it. But what are you going to do? The South is a nice place to visit because everything is cheap. Because everyone is poor. So everything is cheap. It's an interesting place to visit because a great many people in the South have very different ideas about race than we do in Canada. For example, I went into a Krispy Kreme once, and because I don't see people's color, I don't notice this stuff. So I drove into the Krispy Kreme parking lot, got out of my car, walked into the Krispy Kreme like you do. I was going to get me a dozen Krispy Kreme donuts. I'd never had a Krispy Kreme donut before, so I was going to get me a dozen Krispy Kreme donuts. I walked in, I opened the door. Now, have any of you been to the Krispy Kreme in Delta when they're actually making the donuts? It's crazy busy when they're actually making Krispy Kreme donuts. It's like a factory in there. Everybody was working, making donuts. The machine's going. I open the door, it goes bada-bing, bada-bing, bada-bing. It makes this noise because there's a customer coming in. And everybody stopped working. The machines did not stop. It was like on a cartoon where the people stop and the factory keeps going and the stuff falls off the end. It was like that. Know why? In Deep knows why. Why did everybody stop working in Deep? I think you know. I was the only white guy in the place. The only white guy in the place. Then I was like, hey! And everybody stopped and nobody talked to me. I was like, oh, this is weird. And then I looked outside and I looked in the parking lot. Guess what? Busy shopping mall. Guess what? Not one white person. Not one. Oh, this is strange. Bought my donuts. Everyone's like, yes, sir. No, sir. Yes, sir. No, sir. And this was like 15 years ago. So I was only like 25. Yes, sir. No, sir. Yes, sir. No, sir. No talk. No how's your day. Nothing. Just out the door. I get back in the car. Nobody said hi to me on the way. Everywhere else in the South, you walking in the parking lot. Hey, how y'all doing? Oh, I'm great. Oh, you got some funny accent. You not from around here. No, I'm not, sir. I'm from Canada. Canada? You're joking. You drove here from Canada? Yes, I did. But not there. That was South Carolina. One of the most difficult states to be any color other than white. It is a very difficult place to be. I went to the beach, and I got out a skimboard. You guys know what skimboards are? You throw them on the ground, you run, you jump on them, you slide. Right? It's super fun. I parked at the beach, I opened up my trunk, I pulled up my skimboard. There's a family beside me, family of all black kids. They're all looking at my skimboard. And I'm pulling my skimboard out. And I skimboarded when I was a little kid, but now I was older. And the kids are looking at my skimboard. I'm like, hey, you guys know how to ride these things? They're like, so I didn't say anything. And I waited a second. They didn't answer. Their parents were looking at me. You just throw it on the ground and run and jump on it, right? And they all went. And then the littlest one said, yeah, that's how you do it, mister. And the parents were, shh. I didn't think anything about it. We go down to the beach. I'm skimming on my skimboard. Bunch of kids come over to watch. Some white kids, some black kids. Throw the skimboard, jump on the skimboard, ride the skimboard. Now, I don't know if you guys have noticed. I'm a little bit fat. And skimboarding is hard work. You got to throw it and then run really fast and then jump on it. And then you only go like 40 feet unless you kick it with your foot and then run some more and jump on it again. You do that once or twice in 40-degree heat. When you're a little bit fat, you're pretty much finished skimboarding. So I was like, ugh, I'm going in the ocean. And the ocean in South Carolina is about as warm as urine. I know, right? Ew! It's super hot out, and you go, I'm going to go in the ocean, I'm so hot. You jump in the ocean, and it's warmer than any pool you have ever been in. And it's the ocean. It's gross. I don't know why people like it. So anyway, I'm in the ocean, and I'm swimming out, I'm in the ocean. I'm really deep for me. Like, I'm up to here on me. And I look back, and I see this nose coming through the water. Like, what the hell's going on? And I look, and it's one of the little black kids, and he's out to me. Hey, mister. Yeah, kid. Can we use the skimboard? I said, when I went swimming, I said you guys could play with the skimboard. Just take turns. So the kid then says, you're not from around here, are you, mister? No. You think those kids are going to let us touch the skimboard? I had to go back all the way in and yell at the white kids. Because they wouldn't take turns and let the black kids touch it. Crazy, hey? Can you believe that? And that was actually true. Let's do math. How did that even come up? All y'all. That's how it started. Yeah. I didn't even go back and make fun of them. I didn't even go back and say, oh, y'all's being stupid. Because I was a little bit worried that one of their parents might have had a gun in the sand. So I was very quiet when I told the white kids they were being stupid. All right, let's do math. You already know how to do this. Is that a shortcut situation? Is it? If you want it to be. But for teaching purposes, it's x squared plus 4x minus 16, yeah? What happens in the middle? They disappear because 4 minus 4 is 0x, and we don't write it. So we get x squared minus 16. What do we notice about x squared and 16? They have square roots. What math is that? What's the answer when you subtract things? The difference. So this is a difference of squares. If term 1 minus term 2, no matter what they are, if that's a perfect square, and that's a perfect square, the answer is always the square root of term 1 plus the square root of term 2, and then you write it again with the same thing minus. And it always works. Is everybody cool? Let's do an easy one. Is that a perfect square? Yes, it is. Why? Because I can take a square root of x to the 16th, can't I? That is x to the 8th and x to the 8th, because x times x is x, and 8 plus 8 is 16, correct? Is 1 a perfect square? 1 doesn't have a square root? Sure it does. What is it? 1, because 1 times 1 is 1. So, does that have a square root? So what's the square root of the second term? So we write plus 1 and minus 1. Now, how many of you want to stop there? You've done it. Square root, I'm done. What do you see there and there? You see a square root minus another square root. So can I stop? No. I got to go again. But can I forget about this guy? Some of you will. X to the 8th plus 1. So this is now x to the what? 2? 4. Plus, what's the square root of 1? 1. And then that's going to get me x to the 4th minus 1. Can I stop? Why not? Square and square. Oh, damn. X to the 8th plus 1. X to the 4th plus 1. What's this one? Sixteen, 8, 4, 2 plus 1. X to the 2 minus 1. Can I stop there? No. Squared, squared. X to the 8th plus 1. X to the 4th plus 1. X squared plus 1. Then x plus 1 and x minus 1. Can I stop there? Finally, I can stop. Now, notice in this one, I'm starting with difficult ones right away, aren't I? Because it's a very simple concept, yeah? So let's look at this one. There is term 1. Is that a perfect square? Sure it is. Because if it was just y squared, it would be y and y. If it was just x squared, it'd be x and x. But it's both of them, so it's x and y. Is term 2 a perfect square? Yes, because you've got that memorized. What's the square root of 15? What's the square root of 225? Plus 15, and then I just write it again. Minus 15. Any problems? They're super easy until something weird happens. Let's try 3. Is term 1 a perfect square? Can I split 8 z's into 2 equal groups? Yeah, how? 4. So it's z to the 4th and z to the 4th. Is term 2 a perfect square? What is it? Plus 12 minus 12. Now, can I stop? That's a perfect square. That's subtraction. Is that a perfect square? Is 12 a perfect square? No. So I'm done. Everybody good? All right. Now, 4 is the first tricky thing. If there was no 4 there, could you do this? Okay. Oh, wait, sorry. If there was no 4 and no 25, could you do that? What would it be? What's the square root of x to the 6th? X cubed and x cubed. What's the square root of y squared? Plus y plus y. Agreed? Except there's a 4 and a 5 there. Is 4 a perfect square? What's the square root? 2. Is 25 a perfect square? What's the square root? 5. Does everyone see how that one works? 2x. Does everyone see how that one works? See how it follows the rules? Because it's a square minus a square, we can do that. We take the square root of 4x to the 6th, which is square root of 4 times x times x times x times x times x times x. Out comes the 2, 1 group of 2, 2 groups of 2, 3 groups of 2, 2x cubed. Does everyone see how it works? Now, you guys are smart people. Would I leave this much white space if it was actually that easy? All right, we're going to do one of these first. 9x to the 4th minus 16x 16 y squared. What's that one? We're going to build up to the most complicated one. What's that one? 3x squared plus 4y, and then I just write it again. Can everyone do that one? That's level 1 of the tricky ones. Let's move on to level 2 of the tricky ones. This is level 1 of trickery. This is level 2 of trickery. What would I do? Pardon me, Charlotte? They don't have square roots. Isn't there something we're supposed to do first? Let's go back to where we were. Does that help us? Is there a common factor to 27 and 48? What is it? What number goes into 27 and 48? 3. So that means I could divide all of this by 3. Is there anything else common? X. So I get 3x, 9x to the 4th, minus 16y squared. Oh, we know how to deal with that, don't we? 3x squared minus 4y, 3x squared plus 4y. That's level 2. Does everybody understand? It's the same thing. If you can take something out, you take it out, and then the same rules apply. Everybody good? Yeah? All right. Let's try level 3 trickery. Level 3 trickery is this. I already gave you a way to make this look easier. You guys got a lot to say to each other. You must know how to do it already, right? So who's doing level 3 for me? None of you? But you're all talking, so you must know how to do it, because you're not paying attention when I show you. Huh. Interesting. Okay. Who has an idea for how to fix this up? I know a great many of you will do a very long way to fix this. And you'll get the right answer, but it will take you forever. And hopefully some of you will notice a very easy shortcut that I have already showed you today. Ooh, I guess we'll do it when you get... Now, I asked you if you could come up with a way to solve that. There are 2 ways you could do it. There's the way that most people try at first, which will work, but it's a pain. Most people, kids especially, say, I don't like this. So they do this. X plus 7 minus 9. Then they get x squared plus 14x plus 49 minus 9, x squared plus 14x plus 40. Then they have to multiply to 40 and add to 14. So it's 10 and 4. So they do x plus 10 and x plus 4. Phew! Lot of work. The more astute members of the class will remember that I gave them a handy little trick. Make that a. A squared minus 9 is a plus 3, a minus 3. A is x plus 7. 7 plus 3, x plus 10. 7 minus 3, x plus 4. Much faster, much tidier. Do I care which one you use? No. But if you do the red one and you're bad at expanding, you're going to get the wrong answer. If you use the pink one, you really can't get the wrong answer, because all you got to do is add or subtract. Okay? Okay. And the level 4. The most difficult kind of difference of squares I can give you. X plus 2 squared minus x minus 8 squared. That's the hardest one. But of course, if you've been paying attention, you can make this guy A and you can make this guy B. And all of a sudden, you have a squared minus b squared, which is a plus b, a minus b. A is x plus 2 plus x minus 8. So x plus x plus x is 2x, right? And 2 plus negative 8 is minus 6. And then a minus b, x minus x is nothing. And 2 minus minus 8 is positive 10. Then, of course, you would factor a 2 out of there and be left with x minus 3 times 10. If you didn't understand what I did there, stop me now so I can explain it better. Yep. So, I'm going to erase it all and ask where you're lost. Are you comfortable with calling that guy A and that guy B? Yeah, I understand. So you're comfortable with A squared minus B squared. And you know that that's a squared minus a squared, right? So you know it's the square root of the first one, which is A, right? Plus the square root of the second one, which is B, correct? So A was x plus 2. So I had x plus 2 plus B, x minus 8, correct? X plus x is 2x. 2 and minus 8 is negative 6. Are you cool? Okay. And then over here, I'll use a different color to make it easier. Over here, I had A minus B, right? And A is x plus 2 minus x minus 8. Well, x minus x is 0. 2 minus minus 8 is 2 plus 8, which is 10, correct? Then I notice that, oh, this guy can give me a 2, right? So out comes a 2, and that leaves me with x minus 3 times 10. Now, I could go one step further and put that 10 with the 2 and get 20 x minus 3. I'd be perfectly happy with that. Is everybody good with differences of squares? All 4 levels of trickery. Yeah? All right. So now, that's all the easy kinds of factoring. Most of your teachers in grade 10 probably taught you to factor in a similar way for these 3. If they didn't, and you know a different way of doing it, that's cool. Are you allowed to do it? Of course you are. I don't care. I'm going to stop now and let you practice a crap ton of these ones. But the next thing, I factor them in a way that is totally different, I guarantee, from the way you learn to factor the next thing. But my way is very, very much easier. So I'm going to stop for a moment and let you practice with this. Now, on page 134, you're going to do that. There's nothing tricky. On page 135, you're going to do that. There's nothing tricky. Page 136, you will find to be a little bit difficult. All right? The last thing we did as a class was this page for marks. It was out of 12. Yes? So when you get to 134, I'm going to call 134 an assignment, but I'm going to not call 135 an assignment. Now, for those of you that are not taking this very seriously, you will notice down the right-hand side here what word is missing that was in every previous unit. Review. Because we're doing review all the way through. All of these assignments are your review for this particular unit. Right? Because there's no way to make it tricky. It's always the same thing, right? You just need to practice it. So I'm done with the basic factoring. You have, it is 12:23. I think you will be comfortably done 134, 135, and 136 if I give you till 1 o'clock. That should easily get you through that. Hopefully, it will get you through with enough time for me to go over it, and we will have our quiz on all types of factoring except the yuckiest type of factoring tomorrow morning. Okay? Okay. Go. I will be marking your tests if you need me. Notes, person, me. That's the order. I will help you gladly. If I get all the tests marked, which I should because I got the multiple choice done already, if I get all the tests marked, we'll go over it today and I'll hand it back to you. If I don't get all the tests marked, that'll just slide over till tomorrow. Okay? Okay. Plus, I have these quizzes to hand back to you, which I also will want to go over today. 134, I think. Alrighty then. Okay, let's do it. Let's do it. Hey guys, watch this. This is way more effective. Hi Trinity, how's it going? See? Then the girls will talk to you. Don't need to throw rocks at them. Okay? It's real easy. Watch how well it works. I'll try it on everybody and I'll show you how good it works. Okay? Hey Charlotte, how's it going? You have a good weekend? Cool. Right? Hey Prusha, how's it going? You like those chips? I'm not a fan of ketchup, but you know they're one of the most popular chips in Canada, and it's only Canadians that like ketchup chips. Americans don't have them. See how that they talk to you. Now let's do what you did. Take your stuff. See how that works? It's way better when you talk to them. Okay, is it a square? You don't know if 1 over 9 is a perfect square?
I don't. I don't think so.
Okay, well, if it was a perfect square, then you could do... Where the hell did it go? Do that. We just did a test on this. Isn't that the square root of 1 over the square root of 9? What's the square root of 1? What's the square root of 9? So it's a perfect perfect square? So is that square minus square?
Thank you.
No problem. That's what I'm here for. Yep. All right, in 3 minutes you're having your quiz because everybody's talking, so everybody must know what they're doing. I'll start my timer now. You obviously don't need any time to do it, and since no one's asking me and just talking to each other, there is no need for me to teach it anymore. So we'll be quizzing in 2.5 minutes. What did I just say? Should I say it slower? I'll say it slower. Everyone is talking, which means they aren't working, which means they are done. And since no one asked me for help, that must mean everybody can do this, which means I can write a test. Right? Maybe in the next 3 minutes you guys will shut up and do some work, and I'll change my mind. But now you're down to 2 minutes to make that happen. Let's see how that goes. Yep. Yep. Well, that was 3 minutes. That was a much more pleasant 2 minutes of work. Well done, ladies and gentlemen. Let's see how that carries on, shall we? Yes, Josh.
For questions like this right here, you get 6, and then in brackets you get like x squared minus 2. Would you go further?
You can't go further because 2 doesn't have a square root.
And so you just leave like
You would
that?
leave it. But if that 2 was a 1, for example, you would have to go further.
Okay.
Good question. All done? Come on up and get your quiz. Then stop being a waste of time and do something. Or don't come. I just don't understand. Why would you come here all day to flip bottles? Go sit in front of the library and flip bottles. Then you don't have to be here putting up with this. If you don't want to be here, don't come. I won't be hurt. Okay? I got enough friends. Okay? Unbelievable. You. No, 27th.